write the equation of the exponential function that goes through the points 2 and y is 0.36 and 4 and y is 0.1296. Then sketch a graph of the function. All right, great. Let's get started here. I'll zoom. Well, I don't need to zoom in. That's fine. So I'm going to write two equations, right? And they're both going to be of the form y equals a times b to the x power. So I'm assuming that this isn't being shifted up or down, and that the asymptote is the line x is 0. I'm sorry, the asymptote is the line y is equal to 0. And let's go ahead and write both of these. So the first equation is going to be y, which is 0.36 equals a times b raised to the second power. Right, so you can see I'm using the variables I have from these 2 points to try and help figure out what my parameters are. X and y are the variables, a and b are parameters that will describe this particular exponential curve. So the other one we have is that 0.1296 is equal to a times b raised to the 4th power. So we need to figure out what both a and b are. And I think my favorite way of thinking about this now is to get a alone in just one of the equations. So if I get a alone in this first equation, I'm going to do that by dividing both sides by b squared. I get the following: 0.36 divided by b to the second power is a. What I'm going to do now is I'm going to use this expression for a, and I'm going to substitute it into this second equation for a. I really like how this looks. So now I've got 0.1296 equals a, which is 0.36 divided by b squared times b to the 4th power. Well, this is cool because I can see I've got this denominator of b squared, and I'm multiplying by b to the 4th. So this can be simplified, right? This can be 0.1296 equals 0.36 times b to the second power, right? Because b to the 4th over b squared is b to the second power. So now let me take the 0.1296, I'm using this on my physical calculator, and divide that by 0.36. And when I do that, what? I got 0.36. So I divided both sides by 0.36, and on the left hand side 0.1296 divided by 0.36 gave me 0.36, and that equals b squared. So if I want to figure out what b is, right, this is easy and we know what the answer is. I just want to make sure you understand how to do it if it's not there. I'm going to take the square root of both sides. If that was b to the 5th, I'd be taking the 5th root. Another option is to raise, in fact let me show that, is to raise to powers. So I'm not fond of this color. Let me grab this color instead. So if I was to raise both sides to the 1/2 power, this is the same thing as taking the square root. What I like about it is if you get interesting roots, you don't know how to deal with this works. So b to the second to the 1/2 power gives me just plain old b, right? Because you know it's 2 times a half is 1. And on the other side I've got 0.36, and I'm going to raise that to the 0.5 power, and that should be like 0.6, and it is. That's happy. That's cool. So b is 0.6. So I know one of my two parameters. I know that b is 0.6. So I can almost write the equation, right? I got what b is, check, that's great. I just need to know what the other parameter what is, and the other parameter is a, and I have this beautiful, look at this, it's just right here saying, hey, I'll tell you what a is. So I'm just going to take this value of b that we found, and we're going to plug this in for b into here. So 0.36 divided by this point, oh, are you kidding? 0.6, but I've got to square that. That's going to give me what a is. I think a is the number 1, because look, I've got 0.36, and I'm going to divide that by 0.6 to the second power. And when I do that, I get that a is 1. So 1 is the value of a. A is 1. So we now know we know a and our b values, so we can write the equation. The equation is y is equal to 1 times 0.6 to the x power. Y equals 1 times 0.6 to the x power. So I think I can graph this then. Let's come over here to this little piece of graph paper. Let me rewrite that. Y is equal to 1 times 0.6 to the x power. So if x is 0, right, 6 to the 0 power is 1, that just becomes 1. So that's nice. That's a point I have. And then if x is 1, I've got 1 times 0.6, which is 0.6. So at 1, I'm at not a half, but 0.6. And then I'm at 0.6 of that and 0.6 of that. So this gets very small. Let's go the other direction a little bit. Let's take a negative 1. So if I take 1 times 0.6 to the negative 1 power, that gives me 1 2/3. 1.6 at 1 2/3, which is about like here. And if I plugged in the negative 2, that would give me, and yes, I am using a calculator here, that would give me 2.77. So here is about 2.77. And if I plug in a negative 3, the negative 3 gives me 4.6, so about here. So I have a pretty good idea of what this curve is doing, so I'm just going to go ahead and sketch it. And I probably didn't need to do as many points as I did, but here it is. Definitely I've got this y-intercept right there, a fabulous y-intercept, and then I'm just going to continue down here. Being very careful to get close to the x-axis, right? To get close to that line y equals 0, which is also the x-axis, but not cross it because this is it's an asymptote. All right. Absolutely wonderful. That's the end of question 70.